Hi, so for today we're going to talk about the power rule in derivatives. So this is one of the basic differentiation formulas wherein it is called the power rule. So this is a part of our differential calculus topic, and the power rule is one of the most used rule when it comes to differentiation, okay, or getting the derivative of a certain function. So what is the power rule? So the power rule, for example, we have to get the derivative of this expression x raised to n. So if you get a derivative of that, the power rule simply states that this n will be multiplied, okay, by the same function, but the n exponent would be um, subtracted by 1. So the formula will be n multiplied by x raised to n minus 1, where n is any number. Okay? N is any number or integer. Okay, so let's try to get the derivative of a certain function on our first example. Okay, and by the way, if we get the derivative of any constant, let's say any number, okay, any number 4, okay, 1, negative 1, 2, 1,000, 1,000,000. If you get the derivative of that with respect to a certain variable, okay, the derivative always of a constant is 0. So if we get the derivative of any constant c, okay, that would be equal to 0, where c is any constant value. Okay? So here in our first example, find y prime. That indicates y prime indicates our derivative of the function y equals 4 plus 2x minus 3x squared minus 5x cubed minus 8x raised to 4 plus 9x raised to 5. Okay, so the very first thing we're going to do here is to get the derivative of y with respect to x, since our function y is expressed in terms of x. So the variable could be changed. Okay, so how are we going to differentiate that? So we're going to differentiate, okay, each of the terms here with respect to x. Okay, so we have d all over dx here. Okay, we have 3x squared here. Let me just rewrite this. So we have 3x squared here minus the derivative of this 5x cubed minus d all over dx of negative 8 or 8x raised to 4, because I have already written the sign here. Okay, 8x raised to 4 plus d all over dx of 9x raised to 5. So we will be evaluating, okay, if we have a sum and difference function, we will be evaluating individually, okay, the derivatives of each term. Okay, just like what we did here. So, and again, for the very first term here, the derivative of 4, as I have said, wherein 4 is a constant, so the derivative of a constant, according to our formula, would be 0. Okay? So that would be 0. And then plus, of course, I can factor out 2 outside of the derivative. Okay? Because that's a constant. Or we can simply get the derivative of this, okay? But the derivative is still the same. If you can skip this method, but the derivative that you're going to get is still the same. Okay? So since we have a constants here, let me just uh, exclude it out. So we have here, this only applies if, of course, if the function is multiplied to a certain variable. Okay? So plus we have 9, the derivative of x raised to 5. Okay? So again, this would be 2. And we know that the exponent of x is equal or equals 1. Okay? So what are we going to do here is that this one is our n. So by power rule, we're going to copy 1, multiply it on the whole term, and then copy the x raised to 1, but then we have to subtract 1 here from the exponent because of our formula. So we have x raised to 1 minus 1, and we know x raised to 0, and any variable or any number raised to 0 will become equal to 1. So this would be 2 times 1 times 1. Okay? So the same process here on our second term. So our n here is 2. So we're going to multiply it by 2 as our formula. Okay? And then copy this function 2x squared, okay, minus 1. So we're going to subtract 1 in our formula, okay, on this term. So minus 5. The same thing here. It's just that the n here will become 3. Okay? So we have 3 here. And we can copy x cubed minus 1. Then minus 8. The n here becomes 4. So we multiply it by 4. Then we copy the function with its exponent subtracted by from 1. Okay? 4 minus 1. Then we have plus 9 times the n here would be 5. Okay? And copy the function but subtract 1 from the exponent. So if we're going to simplify this, this would be 2 times 1 times 1. This would be 2 minus 3 times 2 is 6. X squared, or x squared, x raised to 2 minus 1 would be simply x. Minus, we have 5 times 3, that's 15. X raised to 3 minus 1, that is x squared. We have minus 8 times 4, that's 32. And we have x raised to 4 minus 1, that should be x cubed. Plus 9 times 5 would be 45. Okay? X raised to 5 minus 1 would be x raised to 4. And this is our derivative of y with respect to our x. So it's pretty easy, right? Just following the formula and knowing what is the value of n, then applying the formula, and we're good to go. Okay? So that is how we get or we use the power formula. Okay, so for number two problem, we have here y equals 1 all over x plus we have 3 all over x squared plus 2 all over x cubed. So our main goal here is to use the power formula. You can also use quotient method here, okay, in each of the term, but it is more efficient to use the power rule. Why? Because if we are going to recall our knowledge in terms of exponents, okay, exponential properties, we can rewrite this y as this has an exponent of 1, So if we are going to reciprocate this, we are going to simply what? Okay? Negate its exponent. So we have already an n equals negative 1. Okay? And for this, if we're going to get, okay, reciprocate this, so this is equal to 1 all over x squared. Agree? And this is also equal to plus 2, 1 all over x cubed. So this 3 all over x squared and 3 multiplied by 1 all over x squared is the same. So applying the exponential, reciprocal this, so we have 3x raised to negative 2. Okay? Then we have plus 2x raised to negative 3. And Viola, we can now find the value of y prime. What is the value of y prime? So the value of y prime, okay, using what? Using the power formula, okay, we apply it on every term. So we have x raised to negative 1 plus the derivative of 3x raised to negative 2. Then we have plus this 2x raised to negative 3. Okay? So applying the power formula, we have our n here for the first term is negative 1. So we have negative 1 and then multiply it by x raised to negative 1 and then we subtract 1 again from its exponent. And for our second one, we know that even though we did not, okay, transpose this or uh, factor this out, the constant 3 outside of the differential sign, it is still possible. So what are we going to do is that we have multiply it by the negative n or the n, negative 2, that is the n, copy, okay, 3x raised to negative 2, but we're going to what? Have a minus on its exponent. Okay? The same goes here. That is plus. The n here is negative 3. So we multiply it on the whole equation. But the exponent of x must be subtracted. Okay? By 1. Okay. So now we have negative, okay, x raised to negative 2. Negative 1 minus 1 would be negative 2. And of course, this plus sign would become negative because of this. So negative 2 times 3, negative 6. This is a positive sign. So this would be still negative 6. X, okay. X raised to negative 2 minus 1, that should be negative 3. Negative 2 minus 1 is 3. And finally, we have negative 3 times 2. That is also negative 6. Okay. X raised to negative 3 minus 1 is negative 4. So this is now our derivative, but we can still rewrite this as follows. So we have negative 1. To eliminate the negative exponent, we simply do what we did here. Okay? So we reciprocate this so that this becomes negative 1 all over x squared. This one is the same as negative x raised to negative 2. Then we have negative 6 all over x cubed. Okay? Then we have negative 6 all over x raised to 4. Remember that this 6 and this x raised to negative 4 are in multiplication. So we can separate it just like what we did here and then get the reciprocal. Okay? So this would be our final answer or should be our final answer for our derivative. Okay, let's go now to number 3 problem. So for number 3, we have y equals 2x raised to 1 half plus 6x 1 raised to 1 third minus 2x raised to 3 halves. So we get the derivative of that with respect to x. So we have to get the derivative of y with respect to x, dy all over dx, or simply dy prime. Okay? So the y prime would be, this is pretty forward, okay? Straightforward. So our n here, again, we can differentiate it by its term, each term, okay? Applying the property of differentiation, okay? So what will happen here is that we are going to copy the n, which is in this case 1 half, and then we have 2x raised to 1 half minus 1, okay? Then plus, we have 1 third multiplied by 6x raised to 1 third minus 1. And then lastly, we have negative 2. Okay? I mean, the 3 halves because that is our n. So we have 3 halves. Okay, multiplied by 2x raised to 3 halves minus 1. So simply, by simplifying this, okay, we can already get the derivative. So 2 multiplied by 1 half would be simply equal to 1. So this would be x raised to 1 half minus 1. 1 half minus 1 would be negative 1 half. Okay? Plus, we know that this is multiplication. 6 divided by 3 would become 2. So this would become 2. X 1/3 minus 1 would be negative 2/3. Okay? And then, finally, this 3 halves and 2, or this 2 which will cancel, so that you are left with 3 here. So this would become negative 3. Okay? X 3 halves minus 1. Okay, this is 1.5 minus 1 would be 0.5. In fraction form, that is 1 half. Okay, so to eliminate, okay, to make our final answer clear, okay, we have to eliminate the negative exponents by reciprocating them. So we again, we have 1 all over x raised to 1 half plus 2 all over x raised to 2/3. And then we have, finally, we can write this last term as it is. Okay? So 3x minus 3x raised to 1 half. So this should be our final answer for this problem. So for our next problem, we have number 4. We have y equals 2 all over x raised to 1 half plus we have 6x raised to 1/3, okay, minus 2, okay, x raised to 3 halves minus 4 all over x raised to 3 all over 4. So this example is in terms of quotient per term. So what are we going to do is to reciprocate, okay, the denominator and negate the exponent in order for us to perform the power rule. So we have y, okay, we can rewrite this as y. So I have y, 2x raised to negative 1 half plus 6x raised to negative 1/3 minus 2x raised to negative 3 halves. Then we have minus 4x raised to negative 3/4. And then we can now apply the power rule, getting the y prime. So what will happen is that we are going to differentiate this again. Okay. For each term, we're going to differentiate it. So we have 6x raised to negative 1/3. Okay. And then we have minus the derivative of 2x raised to negative 3 halves. Then we have minus, okay, 4x raised to negative 3/4. So getting the derivative using power rule, so we have negative 1 half multiplied by 2x raised to negative 1 half minus 1, the exponent. Then we have plus multiplied by negative 1/3. This is our n. Then we have 6x raised to negative 1/3 minus 1 minus, okay, I've included already the sign. So we have negative 3 halves, okay, multiplied by 2x raised to negative 3 halves minus 1 minus, we have negative 3 all over 4 because of this n. Okay, and then we have 4x raised to negative 3 all over 4 minus 1. Okay, so again, as you can see, 1 half, negative 1 half, and this 2 will cancel when multiplied. But don't forget, we have a negative here. So this would be negative 1 multiplied by this term. So we have x negative 1 half minus 1. So this is the same sign, negative 1 half, and this one becomes negative also because of the minus. So if we simplify this, okay, it's just like we are adding 1 half and 1. So this would become negative 3 halves. Okay. So negative 1 half minus 1 is negative 3 halves. Same sign, they will add and copy the negative sign. And then, as you can see here, 6 divided by 3. Okay. So this is multiplied. Negative 1/3 times 6. So this would become plus and minus or negative. So this would be negative 2. Okay. So I hope you get that because negative 1/3 multiplied by 6 would be negative 6 all over 3. So we have a negative 2 here and multiplied by the positive still that would become a negative 2. Okay, and that would be x negative 1/3, okay, minus 1. So here's how we can perform this. So we multiply these two, okay, and that would be negative 3. Okay, so if that is negative 3, and then we minus it by negative 1 because of this. So what will happen is that that would be negative 4. Copy the same denominator. That becomes negative 4/3. Okay? So this would be negative 4/3. And then we all know that 3 halves multiplied by 2, the 2's will cancel here. And of course, be careful of the sign. We have minus here. Okay? We have minus here because of this. Okay? And we have negative here because of this negative 3 halves. So negative times negative would become positive 3. So x, of course, we have raised to negative 3 halves minus 1. So again, okay, so we have negative 3 halves, negative 3 halves minus 1. So multiply this. This would be uh, negative 2, okay, minus 3. That is negative 5 all over 2. Okay, so multiply these two. Okay, so that would be 2 minus of the negative 3. Okay, so that would be negative 5 halves. Okay, so negative 5 halves. So that is the exponent on the little algebra on the exponents. Okay, so and of course this last term, so we have the 4's will cancel. Negative 3/4 times 4, the 4's will cancel. And of course, we have minus here because of this. And we have a negative here because of this negative 3/4. So negative times negative would become plus 3x raised to, of course, negative 3/4 minus 1. 4 times 1, okay, would be 4. Okay. Negative 4 because of this. So negative 4 minus 3 would become negative 7 all over, copy the same denominator, all over negatives, all over 4, I mean. Okay. So this is our final answer as our y prime. Okay. So, but to make it neat, we can, okay, eliminate the negative by getting the reciprocal of those. So we have negative 1 all over x raised to 3 halves minus 2 all over x raised to 4/3. Okay, and then plus 3 all over x raised to 5 halves. Then we have plus 3 all over x raised to 7 all over 4. So this would be our final answer for this problem of finding the derivative. Okay, let's go now to our last problem for this video. Okay, so we have y equals the cube root of 3x squared minus 1 all over the square root of 5x. So the very first thing we're going to do here is if we are in getting the derivative of a radical, make sure to express it in terms of its exponential form. Okay? So we know that if we are going to transpose this or rewrite this into its exponential form, okay, we are going to recall our knowledge about the radical and the exponents. Okay? So what are we going to do here is that we know that this 3x squared is in all inside of the cube root. So we can now have 3x squared and the cube root is simply raised to 1/3. Just as like if we have square root of x, that is equal to x raised to 1 half. Okay? Or if we have x raised to 3 cube root of x cube, so that could be x cube. Okay? And this is the 1 half. Okay? Or this can be rewritten as x raised to 3 halves. Okay. The same thing that we did here, we know that this whole 3x squared is in the cube root, so that we have 3x squared raised to 1/3. Okay, where is that 1? Because this whole thing is raised to 1, even though it's not said, but it's actually raised to 1. So we convert now this radical form into exponential. And we have 1 all over this 5x is inside the square root, of which we know that the square root is, if we convert that, that should be raised to 1 half. So, again, there's something wrong still with this second term because we have to get the reciprocal of this in order to perform the power rule. So, we have 3x squared raised to 1/3 minus we have, okay, 5x raised to negative 1 half. Okay? Okay. So, applying the power formula here. So, we have 1/3. And then we have 3x squared. Okay? Okay. So, we have 3x squared. Okay? Raised to 1/3 minus 1. But, guys, okay, we have still to differentiate the inside function because I forgot that this is a quotient or a chain rule problem also. So, we applied power rule. So, we have 1/3 here. Okay, this is clear. And then, we have copied the 3x squared, 1 raised to 1/3 minus 1. That's the power rule. We are done with the power rule. But according to chain rule, of course, we are still going to get the derivative of the inside function of this. So this would be 6x by applying power rule again here. Okay? So we have minus, okay, negative 1 half because of our n here. And then we have 5x raised to negative 1 half minus 1. And then getting the derivative of 5x, the inside function. Okay? I'm so sorry, I've included a problem that has already a chain rule. Anyway, if you haven't watched my video, please check it out. So we're going to multiply the whole equation by the derivative of the inside function after we get the power formula, after we apply the power formula, because that is the chain rule. So we have 5x, the derivative of 5x with respect to x would be 5. So again, if we simplify all of this, the 3's will cancel. Okay? So that we have the 6x, okay? And then, I'm sorry, this should not cancel. Why? Because, okay, we cannot cancel this 2 3's here. It's because this 1/3 as an exponent of 1 and this 3x squared does not have an exponent of 1, whereas it is 1/3 minus 1, so we cannot do the cancellation here. But we can do the cancellation here in this 6 because both of them has an exponent of 1. So 6 divided by 3, this becomes 2x, okay? Then multiplied by 3x squared, 1/3 minus 1, okay, would be 3 times 1, that should be 3, minus 1, that should be 3 minus 1, okay? I mean, we can rewrite this in order for us to simply uh, know how to calculate this. So we have 3 times negative 1, that's negative 3, okay? So, plus 1, that is negative 2 all over 3. So, this should be negative 2/3. Don't get me wrong. Okay, we are applying the same principle a while ago. Okay. So, this is the same as this. We just flip the changes or the position of this two terms. Okay, so that it is easier for us to calculate this. So that would be 3x squared raised to negative 2/3. Let me just rewrite this. Okay, and then of course, what will happen? We cannot simplify, okay, these 5 halves. So we have negative times negative, that should become positive. Okay, 1/2 times 5, that should be 5 halves. Okay, and then we have 5x negative 1/2 minus 1. Okay, negative 1/2 minus 1. So that would be just like adding 1/2 and 1, but negatively. So that would be 1.5 or negative 1.5, so negative 3 halves. Okay, so we can eliminate the negative in the exponent by reciprocal, getting the reciprocal of this. So we have 3x squared raised to 2/3, and then we have plus, we have 5 all over, okay, 2 multiplied by 5x raised to 3 halves. So this should be our final answer for this problem. Okay, I hope you learned something from this video. If you like this video, please don't forget to subscribe to my channel. So again, our number 5 is, I'm so sorry for that, it has a chain rule in it. I didn't notice that. But still, the problems number 1 to 4 and even 5 has still, we apply the power rule on that. So thank you so much for listening. Again, I hope you learned something from this video. Please don't forget to subscribe and hit the thumbs up on this video. And thank you so much for listening. This is Engineer Abat. God bless you all.